Welcome back. We're going to continue our discussion on reactions of aldehydes and ketones. And we've already looked at one of the nucleophilic addition, that is hydride reduction. The second one we're going to look at is cyanohydrin. We have actually looked at part of it in Chem 330. So we're going to just add on to that knowledge. Again, I've kept my reactants the same. One is an aldehyde, and the other one is a ketone. Now, I'm going to do it for the aldehyde completely, and you're going to replicate it for a ketone. There's not going to be that much different because it's the double bond O that's a key component in this reaction. Okay, we're going to add an HCN. What does that do? Well, later, if you have time, I will come back and actually explain the mechanism for it. But whether it's an aldehyde or ketone, remember, this is the carbon. I'm just going to write the carbon because so that you know what's happening. Write everything the same way. And when you get to the carbon containing the double bond O, basically what happens here is, well, HCN is, I'm just going to give you just a synopsis. HCN exists as H plus and CN minus. Basically, it's an acid. CN minus, we know, is a strong nucleophile, so that's going to attack the carbon containing the double bond O, which in turn generates O minus, which then attracts an H plus, and then we end up with, basically what you're doing is add the hydrogen to the O, which makes it a single bond, because remember, oxygen can only have either two single bonds or one double bond, right? So it was double bond here, but when you add the hydrogen to the oxygen, it becomes a single, and then the CN gets added to the same carbon as well. Basically, the hydrogen goes to the oxygen and the CN goes to the carbon. Okay, that's a short version of the mechanism. I know I've explained the mechanism orally, but if I keep doing it for everyone, it's just going to take forever. All right, now this is the product. That's it. Okay. Now, I've got two more reactions that can be carried out from this as a starting material. Okay, again, this is a reduction, right? So you have to make this. Once you make this, if the reaction were to carried out further using this as the reagent, it's a reduction reaction. So all you're going to do is rewrite everything up until the point containing this and replace the CN with a CH2 and H2. This is a constant, okay? Basically, you're going to replace the CN with a CH2 and H2. Why? Because nitrile, when it undergoes reduction, results in CH2 and H2. Okay, so you went from a nitrile to an amine. Okay, because NH2 is an amine. Okay, or once you get to this point, you can turn this into an acid. Okay, because when nitrile reacts with water or protonated water, which is called hydronium ion on heat, it makes acid. Okay, so write everything again up until what contains the OH, and then replace the CN with the C double bond OH, because that's carboxylic acid, remember? So basically we're replacing again the CN with C triple bond OH. This is an acid. So what I want you to do is take this, again, don't worry about the actual structure because it's the double bond O that's going to play out. So you're going to replicate this whole process and try to do it. If you get it wrong, well, I'll see you in class and you can ask me that. Hey, I tried it. Is this correct? Well, I'll tell you in a second if you did it right or wrong. But just pay attention to what I have done and how I explained it. I didn't just throw things everywhere I like and then say this is what it is, learn it. No, I gave a decent amount of rationale on what I did. Okay, so just that. So try this for ketone on your own. Okay. And then this is called Grignard reaction, okay? So I'm going to actually step back. Again, it's the aldehyde and a ketone. With an aldehyde, okay, and a ketone, we produce alcohol again with the Grignard reaction. Again, R can be CH3 or CH3, CH2, etc. And X means X can be Cl or Br, F or I. Okay, so what if this was CH3 Mg Br? The Mg is a constant factor. I will give it to you this way. The fact MgBr is there, or MgCl or MgF or MgI, I can change the X or I can change the R. The fact is Mg indicates you it's a Grignard reaction. And when this reacts with this, what you're going to end up with there is rewrite this, okay, to the carbon containing the double bond O, and add whatever this is, R value is, add it to this carbon, CH3, and replace the double bond O with an OH. That's why I highlighted the carbon. So the CH3 goes to this carbon, and then, of course, the hydrogen comes from here, okay? Hydrogen comes from here, attacks this. So replace the double bond O with OH, and then whatever the R value is gets added to the carbon that was containing the double bond O. So I have another reaction for you. Using this idea, replicate this and do it for the ketone. Okay, again, the carbon containing the double bond is the focus. The rest of the compound has no bearing on how this reaction will be carried out. All right, so I'm going to stop this here. Again, Grignard reaction is a professional exam magnet. This will be on almost every. What you see is when you start with an aldehyde, okay, and you do a Grignard reaction, you end up with a secondary alcohol. I can give you a tip. If you were to do this right, you will end up with a tertiary alcohol. That means ketone using a Grignard reaction will give you a tertiary alcohol because this is a ketone, and an aldehyde using a Grignard reaction would give you a secondary alcohol. Okay, I'm going to stop this here because I don't want the video to get out of control, but try to listen to what I've said, okay, and then try to replicate it. If needed, create more structures of your own, okay, using the same line structures. Create more structures of your own and try to change the R value, change the X value, come up with interesting different compounds, okay? But at the least, try the one I asked you to do and then ask questions off of it when you see me in class. I will see you with one more video, and I think we will wrap up reactions of aldehydes and ketones in that final video. So stay tuned.